Hi everyone, welcome back to yet another Euphoria Academia YouTube video. My name is Ole, and what we do here is past papers, and today we're just going to do the grade 12 mathematics paper 2 November 2023 paper. We're going to be doing question 3. As stated before, we're going to be doing question 3. It goes from 3.1 all the way up until 3.8 and it counts 20 marks. Right, for question 3.1, we're asked to find the distance or the length of the line SL. So the first thing that we're going to do is write down the distance formula, and then we're just going to substitute. All right, I already started with the question. Let's get into it. So we're going to just substitute. So y2, it doesn't really matter as long as when you do substitute, it's in the right order. Right, so for me, I chose the second y coordinate as s. Right, so I'm just going to say 5 minus 1, and I'm going to square that. I'm just substituting into the formula, and we have 4 minus 4, and the whole bracket is squared. Now, when you enter that into your calculator, you will find that the answer that you get will be 4 times the square root of 5, which is actually equal to 8.94. For 3.2, we're asked to find the gradient of line SN. Right, so before I attempt this question, I encourage you to always fill in the details that you already know. So we know that the distance or the length of line SL is 4 multiplied to the square root of 5. So I'll just put it in the diagram, and now if I encounter a question where I might need the distance, I can use it. Alright, so without further ado, we're just asked here to find the gradient of line SN. And what we're going to do is we're going to use the gradient formula, which is y2 minus y1 over x2 minus x1. Right, now all we're going to do is substitute. And when we substitute, we're going to have 5 minus 3 divided by 4 minus 2. And the answer that we're going to get is 4 over 3. When you put it into a calculator, when you just do the maths. And that is our answer. All right. So we're going to be moving on to question 3.3. And that is asking for the angle of inclination of line SN. And in the previous question, we found the gradient of SN, so we're going to use it in this question. Right? So the formula is tan theta is equal to the gradient of whatever line that we need to find, and in this case is line SN. Right, now all we're going to do is substitute, and we're going to find that the gradient was 4 over 3, and when you find the arctan, we will see that theta will be equal to 53.13 degrees. For question 3.4, we're asked to find the size of angle LNS. In our diagram, that angle is right here. All right, so I can see that we have a right-angled triangle. So that would mean that we can use trig identities, right? So what I'm going to do is I will probably find the sine of that angle, and yeah, I'll look for the sine. But before I can find the sine of that angle, I need to calculate what is line SN. Alright, I need to find what SN is. Okay? And to find SN, I will use the distance formula. So SN is equal to the square root of, I'm just going to substitute in, minus 3 minus 5 squared plus minus 2 minus 4 squared. Right? Just to be clear, I'm using the following coordinates. S was 4 and 5, and N was minus 2 and minus 3. Right? So for me, my y2 and my x2 values came from N. Right? And then I just substituted accordingly. Right. Once you do the maths or put this in your calculator, you will find that Sn is actually equal to 10 units. Alright, now finding Sn, like I said, we're going to use trig, and I'm going to find the sine of the angle LNS, which will be equal to, sine is opposite, what's opposite? SL is opposite, and the hypotenuse is SN. Alright, now we already have SL, we already calculated it, and we found that it was 4 multiplied to the square root of 5 over SN, we just calculated it above, and it was 10 units. And when you do your maths, when you do your maths of that, as well as find the arc sine, you can find that the angle LNS is equal to 63.44 degrees. So for question 3.5, we're asked to determine the equation of the line which passes through L and is parallel to SN. Right? So we're meant to find the line in the form of y is equal to mx plus c, and we know that it's parallel to SN, and whenever you see parallel or perpendicular, you need to consider the gradients. So the gradient of line MSN is equal to 4 over 3, and if this line is parallel to it, that means that it has the same gradient. So I'll just call that gradient M. Right? So we have a gradient, and we have a point called L, and that point called L has the following coordinates, minus 4 and 1. So we're going to find the equation of the line using the gradient form, the gradient point form. And you write it as the following: y minus y1 is equal to m multiplied to x minus x1. Right, so now I'm just going to substitute our y1, which is going to be minus 1, being equal to our gradient is 4 over 3, and that will be x, and then our x1 is minus 4. So we're just going to replace that, and we're going to do some maths. Let me just simplify on the right hand side. We're going to find that this is going to be 4 over 3x plus 16 over 3, and y is actually equal to 4 over 3. I'm just taking the minus 1 to the right hand side, so I'm going to add a 1 on the left hand side and add another 1 on the right hand side. So just continue, that'll be 4 over 3x plus, if we add a 1, we will find that we're going to have 19 over 3. For question 3.6, we're told to find the area of triangle LSN. So the triangle that we have there, right? Now, if you remember that the area of a triangle is equal to half base times its perpendicular height. right? So the perpendicular height of this triangle, we already have it as 4 multiplied to the square root of 5, but we don't have the base, right? Our base will be ln. So we first have to find the length of base ln. So for that, we're going to use the distance equation. Going to say y2 minus y1, that will be squared, and that should be added to x2 minus x1 squared, and we're just going to substitute whatever that we have. So just to recap, our coordinates are for L minus 4 and 1, and then for N, coordinates will be minus 2 and minus 3. You can see it on the diagram there. And then for my y2, I chose that to be the minus 3, and that will be minus 1, and that will be squared, plus x2, sorry, will be that. I apologize for the sound. That would be minus 4. That will be squared. And when we do our arithmetic, we will find that ln is equal to 2 multiplied by the square root of 5. Right, now substituting this into our area equation, that will be area is equal to half base. Our base is 2 multiplied to the square root of 5. Our perpendicular height is 4 multiplied to the square root of 5. And we shall see that our answer will be 20. Our area will be 20 units squared. Question 3.7, we're asked to find point P, which is equidistant from L, N, and S. Equidistant. So it means this point is somewhere in the middle between L, S, and N, right? So we can actually say, or let's rather say this, right? So the coordinates of P will be A and B. We have to find what A and B are, right? So because this point is equidistant, it's the same distance from S, N, and L. That means the lines PN will be equal to PL, which will be equal to PS, because it's the same distance from S, N, and L, right? So knowing that, we can basically have simultaneous equations, right? We're going to have Pn is equal to PL, and we're going to have Pn equal to PS. Right? It's up to you how you write this out. Right? So I'm going to start substituting into our equation 1, and that will be our equation 2. Right? So substituting, I'm gonna substitute basically the distance formula. So the distance formula for that, the distance formula for that, but I'm not going to consider the square root, because the square roots are going to cancel. You're going to have square roots on both sides. So I'm going to write b plus 3 squared, which will be added to a plus 2, which will also be squared, and that will be equal to b, oops, almost forgot the brackets, b minus 1, which will be squared, plus a plus 4, all of that is squared. Expanding the bracket, we will see that we're going to have b squared plus 6b plus 9 plus a squared plus 4a plus 4, that will be equal to b b squared minus 2b plus 1 plus a squared plus 8a plus 16. Right, now after doing our algebra, solving this and gathering like terms, moving things from the left hand side to the right hand side and vice versa, we're going to find that our answer is going to give us 2b minus a is equal to 1, and I think it's easy to make this the subject of the formula. We're going to find, if we make a the subject of the formula rather, we're going to find that a is equal to 2b minus 1, and that can be considered our equation 3. Right? So now let's just simplify our equation 2, and we will find that, also using the distance formula, mind you, we will find that, and expanding as well, let me just write it in full. We're going to find that b plus 3 squared plus a plus 2 squared is going to be equal to b minus 5 squared plus a minus 4 also squared. And that will be our equation 2, and after expanding and such, we're going to find that this equation is going to be 4b plus 3a will be equal to 7, and that's our equation 2. Right. Now we're going to substitute our equation 3 into 2. Right, we're going to find that that is going to be 4b plus 3 multiplied to 2b minus 1, which is equal to 7. Right? And we will find that b will be equal to 1, and a, when we substitute what we have for b into equation 3, a will be equal to 2, we substitute it there, minus 1, a will be equal to 1. So our coordinates for p is 1 and 1. Now for this, we're going to, we're asked to find what LPS is, right? And now LPS is this angle here. I'm just going to highlight it. I already drew the line LP to make things easier. LPS will be this angle here, so the obtuse angle, the one highlighted in blue, right? So I can see that this LPS is next to the purple angle, so the angle called LPN, right? So I'll need to find LPN, and then using the properties of a straight line, I will find LPS. So what is LPN? What is LPN? We're meant to find that. Well, we can see that LPN, it's just that I didn't draw a very straight line, but we can see that our LPN runs from L all the way up until a point P of 1 and 1, right? And the y coordinate of L is also 1, so it's a straight line, right? It's a straight line that is actually parallel with the x-axis. Now, what do we know about parallel lines? We can see that this angle here can be equal to our angle of inclination, which we found earlier in the question as 53.13. Yeah, right? That's 53.13. So we can say that our angle LPN is equal to 53.13 because of alternate angles, right? And then from that, PS plus LPN, that will give us 180 degrees because these are angles on a straight line. Right? So I'm just going to do the substitution. Plus 53.13 degrees is equal to 180, and we will find that our LPS, our angle LPS, will be equal to 126 degrees. There should be a point somewhere, and it will be 0.87 degrees, and that's how we do